Hello everybody. Working with just a classic Bedini coil, but I made a little bit of a modification that's pretty fun to play with. So here we go. Close the book and get it out of the way. And all my assorted batteries and stuff. Welcome to my messy laboratory. I got more projects going on than I can shake a stick at, but anyway, I saw something and I just wanted to make a video about it. Got my Bedini running on 12 volts right there, and anyway, you can take the RPM meter. Hope I don't make you too dizzy doing what I'm doing, but we'll take the RPM meter and we'll take a reading of what's going on. And we're running 1825 RPM right now. Okay? So the difference in my Bedini coil is that I've run the inductor through the center. I made it longer where this other coil can fit on. And right now, as you can tell by my wires, I have it shorted. Okay? And that's the reason it's running 1825 RPM. Alright? Now then, I can take that short off. Boom. No short, and you can listen to the wheels slow down. Okay? I'm just talking about this coil right here. And show you on the RPM meter again. Of course, it's upside down unless I turn the camera upside down, but you can read it. The 1731 RPM. Okay? And of course, that is alternating current that's coming off that coil. And I'm going to take this test light right here. It's hooked up to one side of the coil. I'm going to hook it up to the other. And you'll see my test light come on, and it's burning green and red, which means it's alternating current. Okay? And just wanted to show that faction. Alright, the next thing I wanted to show is I have a 555 capacitor right here. And so I'm going to take this loose, and I'm going to hit that to the common. Okay? And I'm going to take this loose here, and I'm going to put that on the 5 side, 5 microfarad, and you'll hear the wheel slow down. Just almost bogs it down. It'll keep running, but it's bogged down. Okay. And anyway, take an RPM reading again. And we're at 1200 RPM, 1199. So this is kind of hard to do, but I got my voltometer here, and we'll take a reading. I've got it set on the 200 volt AC side, and we're going to measure across the capacitor. See where I got it measured across, and we're reading 22.7 volts AC. Okay, and this meter has a hertz setting on it, so I'm going to go ahead and just turn it to hertz. Okay, I'm going to hook it up to the capacitor again. Kind of hard to do. Okay, and you'll see there we've got 140 hertz. That's in kilohertz, 0.14, that's 140 hertz. Okay, so just wanted to show that. So now I'm going to just short across my light again, and this coil is not loaded up now. And so we're going to drop back down an unshorted coil. RPM will drop on that unshorted coil to 1700 RPM. Short coil get 1800 RPM. Non-shorted coil, nothing. Now I'm not running the variable resistor. I've got it hooked directly across just through a 75 ohm resistor into the light. See what's going on. And now I'm going to go from 12 volts to 24 volts. Okay. So you can see my light over there is brighter. You can see the wheel pick up considerably. And we'll take a reading on that. And you'll see we're at 2506 RPM. And the lots of fun there at 2506 RPM. The only thing is that you'd think the frequency would go up a lot, but as you'll see, I go across the light. Frequency's at 120. I can't quite change it. Now set a frequency 120. So nothing really changed on my frequency, even though I've increased the voltage and RPM has gone up considerably. The point that I was trying to make is that a lot of people, there's 3 magnets on there, and a lot of people think that the frequency is controlled by the magnets, but it's not. And that was the point I was wanting to make, basically for this. So give me just a second here, and I'm going to hook the meter directly up where you can watch it. Take it off the light. Watch the meter one better. Okay. And you can see my meter is staying right at 120 hertz. Okay. The motor side, again, I'll show you. 2538 RPM. Okay. But the frequency is staying at 120. Okay. So just a little food for thought. Now I'm going to drop it back down to 12 volts. Okay. The frequency without the capacitor in there is at 80 hertz, 80 cycles per second. Okay. $80 cycles. Now I'm going to go up my voltage. 120. And grab another lead here. All right. Now 36 volts. Here it take off. .140 hertz. Okay. Speed 2953, 2955, 2957. So that's at 36 volts. Just wanted to show that the frequency doesn't have anything to do with the 3 magnets on there, because if it did, 3 times 3,000 RPM is 9,000 events. That'd be 9,000 hertz, and that's not correct. So anyway, I hope you learned something from the video, and one of the configurations that I play with my little wheel, and desulfating batteries and other things, but that's just a common Bedini setup. And some people ask, I can hook up all the different meters and stuff. The wall wart does make some changes, so I'm going to disconnect from the battery. Okay. And I'm going to hook up the wall wart. And it's a 1.5 amp wall wart. Now, the wall wart has some frequency. It's not completely bridge rectified, but one of the things I love is being able to see how many watts is being drawn off the wall wart that the unit's drawing. And as the motor comes up to speed, it rocks about 10 watts without putting any resistance on it. Okay. The hertz still around 80 hertz, and so now I'm going to take my configuration and go to the resistor. Okay. And I've got the resistor, variable resistor, where it's passing through, so we're still showing, it's got a little bit of resistance, but it's still showing about 10 watts. Okay. I can dial the variable resistor back, and as I do, the my hertz will climb, and I can get up to about 230 hertz with that message, and I can drop it down to 3.5 watts of power going in, and